Hello, and welcome to this Ubisense event, Location Technology in Action. I'm your host, Stephen Manifold, Chief Marketing Officer of Ubisense, and I'm delighted you've chosen to join us today. We've got a great lineup of speakers sharing their experiences of using real-time location technology to improve business processes. Our aim is to pack in as much content as possible into this event, so we'll be moving through the presentations with some pace, but we'll make sure there's plenty of time for your questions. On your panel, as well as the main video stream, you'll find a widget where you can post your questions. These will get fed through to me here in the studio, and I'll do my best to ask as many as possible to our speakers as we go throughout the event. Don't hold back and don't wait till the end. Just fire away as soon as you think of something you'd like to ask. Also, the session today is being recorded, and a link will be sent out after the event, so if you miss something or you'd like to share something with colleagues, you'll be able to do that later. Today, I'm joined by a real mix of Ubisense clients and industry expert speakers from across Europe and North America. Again, you'll see on your panel a widget displaying the full agenda and highlighting which speakers are coming up next. So look, I said we'd move at some pace and pack in as much as possible. So without any delay, let's get started with our first speaker, Clare Colhoun, CEO of Ubisense. Clare has led the team here at Ubisense since early 2019 and joins us from her native island, where she wanted to spend a few minutes welcoming you and outlining what we've got in store for today's session. So I'll let Clare get the event started.
Welcome, everybody. Thank you for attending and spending the next few hours with us. Today, we are discussing location technologies and the importance of these technologies, and that they are solving significant productivity and quality challenges for our clients. We know that traditional applications do not cater for the needs of manual business processes. Let's take an example on a factory floor, where you might have a forklift picking up an incorrect pallet. Now, if something doesn't intervene, that pallet will arrive line-side with the wrong parts and cause all kinds of delays. That is the type of situation that our technology will address and prevent the wrong parts arriving line-side. So we are committed to closing these data gaps around manual processes. We identify when and why something significant is happening in the unconnected world, and we update traditional business systems accordingly. Now, why are location technologies gaining a lot of traction at this moment? I think there are several reasons for this. One not insignificant one being the capital markets. Capital markets have really started to realize the value proposition that is location technologies, and significant funding has started to pour into location technology companies. There have been several acquisitions, there have been several new companies funded. And for any market to take off in a serious way, we need the capital markets with us. Another one is just familiarity and the technological curve. I mean, these technologies have been around for a while now. People are starting to understand them better. They're getting into the vernacular. People are less hesitant about using them. Another one, of course, is the pandemic. The pandemic has really contributed to a significant problem right across the supply chain. For example, the chip shortage that's happening at the moment. And we can see that in a lot of car plants, there's a lot more WIP piling up because there are shortages, and therefore location technologies are being used in those car plants to help them understand where everything is, where is that work in process. Another one is skill gaps. We know that manufacturing plants are dealing with an aging workforce, so they are using smart technologies to help complement that workforce. So as a result, the demand for our technologies is rapidly increasing. Once again, very delighted to have you all here today, listening and sharing with these stories that we're going to present. First of all, we're going to introduce Richard Hell from Oliver Wyman. Richard is going to share with us his insights from his engagements with leading manufacturing organizations. And we can definitely benefit from what Richard is learning. Then we're going to be joined by Stellantis. Stellantis will be sharing their story about using location technologies to control wireless tools in their production facility in Spain. And they will talk to the productivity and quality improvements that they're seeing as a result. Then a long time and very valued customer, Mercedes-Benz, will speak similarly about using these type of technologies and also how they have developed these into multiple use cases across many sites across the globe. They'll also speak to their experience of leveraging a centralized center of excellence team, and that may be of interest for many people who are listening in on the call today. Then we have another long-term valued customer, Metro Transit, who are using our technology to locate and track hundreds of buses indoors and outdoor depots in Minneapolis and St. Paul's. Metro Transit will share their practical experience of location technologies and their use in harsh environments. They will speak to their experience of our evolution in our technologies and why they recently embarked on a tech refresh. Then finally, we will have Collins Aerospace, a relatively new client. Welcome, Collins. And they will speak to their experience of selecting and getting started with location technologies for logistics use case in Germany and in the US. Then we'll have a wrap up with our own Ubisense team with some live demos. We would like to share with you how we are improving the experience for our users, but also how we are making the technology as easy as possible to plan and deploy. Thank you very much. We'd definitely encourage you to ask as many questions as possible as we go through the presentations today. And now I'm going to hand you back to Stephen.
Thanks, Claire. I think it's fascinating to think about the breadth of organizations that can exploit location and movement data as look at ways to cope with these challenging operating conditions that you talked about. As you talk to Ubisense clients and partners, what changes are you seeing in how they think about using this technology to improve their processes?
Well, Stephen, one of the things that I mentioned when I was introducing this session today is familiarity. So we are finding that partners and customers are becoming more familiar with these technologies, and that means that they're asking less frequently for a proof of concept. The technology has been proven, and more clients and potential clients understand that and are willing to move up the curve quicker. Another one is there's an increasing interest in moving to the cloud. Our technologies obviously are deployed and deployable in the cloud, and many clients are aiming to go that direction. Another one is that we see that clients are interested in a suite of solutions. So, you know, it may be UWB for one use case, it may be BLE for another, it may be 5G for another. And so clients really are looking at a whole end-to-end suite of solutions to make, for example, their factories and their plants more efficient. And of course, in our case, all of these sensors types can be ingested by our SmartSpace software platform. So they're probably some of the more significant things that I'm finding at the moment, Stephen.
Okay, excellent. Thanks, Claire. I'm pretty sure we're going to touch on some of those topics as we go throughout the presentations today. Thanks very much for your introduction. That's a great segue actually to get started with our event with just a short reminder of what's coming up. Right, I'd like to introduce our next speaker, Richard Hell from Oliver Wyman. Richard joins us from Germany, where he leads the manufacturing practice at Oliver Wyman. Usually, Richard can be found spending time with senior manufacturing leaders, helping guide them through large digital transformation projects. To improve processes and reduce costs, he brings his expertise both from himself and also of his organisation. We're really grateful he can share some of those insights with us today.
Well, welcome everybody, and my topic today is the state of manufacturing. And let me assure you that where we are today across the globe on manufacturing is not of anyone would have expected a couple of years ago. So plenty of effects have, well, at least hit our strategy, have influenced the way going forward, and are certainly the kind of challenges we need to deal with today. Let me list out a few of those which have a fundamental impact on where we stand today and where we need to go in the next couple of years to stay competitive with our manufacturing environments. There's definitely really kind of list the most prominent one with COVID-19 and what we have lived through, while it is in the crisis situation in the last, well, it is 1.5, almost 2 years now, which clearly led to, while it is to rapid changes in production volume and massive supply chain disruptions, which even now where manufacturing and our normal operations is going to get more used to the ups and downs and really kind of volumes and challenges, the supply chain disruption is clearly there. There was another effect, which was a change in consumer behavior, which we haven't expected, that all of a sudden some industries were faced with significant drops in volumes. Other, like, for example, consumer electronic had an all-time high in demands from people working from home offices, having more time, spending on really kind of somehow consumer electronics and things like that. And then last but not least, what we also not were used to before the COVID crisis was the situation that all of a sudden we had labor shortages and a lot of uncertainties, and still living in an environment where the number of people being really kind of sick, being out, being quarantined is significantly beyond in what a well-oiled machine on the manufacturing environment was used to. However, independent from COVID and the effect, there is also somehow the end of globalization, or at least the globalization as we were used to in the last couple of years, with a lot of trade wars and unpredictable tariffs between the various different really kind of countries in the world, increasing really kind of protectionism from some of our really kind of countries where we used to sell products or used to really kind of import products, which is leading to rapid changes in legislations, also really kind of challenging the manufacturing environment. And last but not least, we have seen in the last couple of years an increasing vulnerability towards regional catastrophic events, which certainly have brought our entire global idea and global supply chain into some difficult situations. And this is not just since we confronted with COVID. It started really kind of much, much earlier with Fukushima and a couple of other things which had a severe impact on our manufacturing strategy. And then last but not least, I want to also point to, while it is climate and sustainability, the whole discussion on decarbonization, on carbon-free, CO2-free really kind of environments. One of the effects is clearly for the automotive industry, but also for aerospace and others, the push towards e-mobility and really kind of hydrogen as one of our sources for, well, it is the fuel sources we need to deal with. And last but not least, also really kind of particular in the last couple of days, as we have seen that environmental friendliness is a buying criteria, as well as it becomes more and more a criteria for investors in looking at really kind of how companies are performing and what the company's strategies are towards really kind of climate and sustainability. So all over, significant changes, which this goes without saying, do have a quite severe impact on our manufacturing strategies and what companies need to deal with. So that results clearly into some internal challenges we are hearing in all our conversations with clients in automotive, in general manufacturing, in aerospace, more and more loudly in the last really kind of this couple of months. And if I can start on the left side, the entire topic on complexity, where we do see that there is still really kind of an increasing rate of complexity coming purely from new technology and all the challenges which are going along with those technology changes in the industry. Increasing number of variations and variants of products as well as process. I talked in my earlier slide of e-mobility, just really kind of look from an automotive perspective, that all of a sudden you produce the same vehicle as an ICE, as really kind of an hybrid and a fully really kind of battery electrical vehicle. So that alone has a massive impact on the number of variants you need to handle in a manufacturing environment. And last but not least on that complexity topic, I like to call out the independencies between systems, component, and really kind of also peripheral systems, which are increasingly making really kind of our life complex. That results into the new theme of manufacturing on a more resilient environment. And what that means in detail, if we really kind of dive a level below, clearly means a new manufacturing strategy, moving to more flexible manufacturing concepts, which are able to adapt just really kind of much quicker to changes in the marketplace. And that can be really kind of increasing or decreasing volumes. This could also be a change in really kind of your manufacturing programs. Certainly, I think the world was confronted with a situation which forced us to rethink those manufacturing strategy, which we have optimized over the years and years and years, and really kind of geared towards consistent really kind of volume, while it is output, which are not there anymore. On the supplier ecosystem side, resilience clearly means in redefining your make versus buy, in rethinking every cornerstone, in whether you're going to put it in your own manufacturing plants, whether you're going to buy it, how you're going to change on that environment in order to reduce purely the vulnerability on supply chain disruptions, which are making all our lives significantly more complicated in the last decade here. And last but not least, there's another trend which feeds into that resilient manufacturing demand or really kind of ask from our clients and top management, which purely has to do with your workforce. We clearly need to adapt to changing skill requirements coming from technologies, coming from a higher level of digitalization. And last but not least, also an effect which we're going to see, particularly with the new generation, which actually really kind of starts coming in our manufacturing lives, which definitely have a different work-life quality aspects, which are important to them and need to be considered as we define our future manufacturing strategies. And last but not least, there is the everlasting topic of efficiency, which I do think really kind of gets under growing pressure and growing concern purely from the fact that all those investments which needs to be made from our companies in that technology change and in a fundamental really kind of this different, let's say, technology generation costs a lot of money and needs to be financed by demanding really kind of higher efficiencies and really kind of cost savings in the current environment. There is another effect which clearly really kind of has to do with the fact to stay competitive in a market where we're going to find really kind of new incumbent players, particularly while it is all our guests today on the automotive environment. I do think we are confronted with companies who never actually were seen on the automotive horizon and all of a sudden coming into discussion in also start building car, whether that are consumer electronic companies like Apple, like really kind of Foxconn, which certainly talking today to build vehicles, or other constellations, certainly having no heritage, having no really kind of somehow large baggage of investments which they need to afford, certainly can produce much, much more efficient and much, much cheaper in a sense, which we all need to quality deal with. And last but not least, we need to absorb the overshoots of those increasing number of product launches, which we clearly are seeing in the last couple of months. And if we're going to qualities project that to the year 2022, 2023, we still have a massive amount of launches of new vehicles and also really kind of new aircrafts, particularly if you're talking, look at the environment of VTOLs and really kind of city taxis and all the new way of transportation, which certainly really kind of is new to the market. So what does that quality somehow mean in terms of considering really kind of to accelerate the transition? There is certainly one thing which is present really kind of all the time, but from my perspective is coming more and more important, and that is the reduction of complexity. So standardizing offers from what you're going to put on the market, what you're going to offer to the clients, but particularly also rethinking how you're going to really kind of design products and put that theme of design for manufacturability and assembly much, much more in the center of what you're going to do. There is a second element around really kind of manufacturing concepts in dealing with the challenge of existing really kind of manufacturing concepts, adjusting towards that increasing number of variants and certainly really kind of constant decreasing or increasing volumes, which needs to be really kind of accelerated from a transition perspective. My third point would be refining your supplier ecosystem, adapting to qualities the change in value creation in your tier N supplier ecosystem, where you're going to see a shift from what usually was done from the large really kind of tier one and all that really kind of center of gravity was focused there to a much, much more really kind of wider dispersed qualities tier N environment you need to deal with, and you probably really kind of also need to put that in a perspective of a change in terms of global reach, suppliers becoming more regional instead of being really kind of single source suppliers which just existed one time in the world. And last but not least, there is the theme of a consequent digitalization, which certainly will help significantly to accelerate the transformation, which means learning to leverage those digital technologies, digital tools, as one of the core capabilities which allow you to continuously really kind of optimize your environment. Again, here the shift from more conventional ways in efficiency increase and efficiency optimization activities to doing that much, much more in the digital space, which allows us to get actually to new heights, to a new watershed of opportunities, which we haven't actually really kind of being able to leverage so far. So I wanted to leave you with that couple of thoughts. It's certainly a very interesting environment for all of us in the manufacturing space. I think it is a challenging environment which forces us to rethink a lot of qualities of our old common really kind of thoughts and thought models and concepts. But on the other hand, it gives us an opportunity in just really kind of adjusting our manufacturing strategy, discussing, adjusting our activities and get to the next plateau of productivity, just being fit for the future. With that, Stephen, I want to hand back to you.
Richard, thanks again for spending the time with us. That was great for you to talk us through those thoughts. I'm really interested to know, how much of what you've shared today is new from, say, 1 year ago versus, what are you expecting to be talking to people about perhaps 1 year from now? It seems like a lot of change happening quite quickly.
Yes, definitely, Stephen. And first and foremost, I think that concept of resilient manufacturing is really kind of new to all of us. And I think we're still grasping in what it really means in all its different facets and fashions. But we're clearly walking away from volume optimized, very, really kind of rigid manufacturing concepts and structures, which weren't probably really kind of able to deal with all the changes from a volume perspective, complexity perspective. So this is what we painfully had to learn, that that world seems to be really kind of a world of the past, and meanwhile, nobody believes that this is coming back. So we all need to understand that better for us what it means. We all need to really kind of rethink in what does that mean, for example, the line-to-the-line design you're going to use. What does it mean for the level of digitalization you're going to use in the plant? And what does it ultimately also mean in how you manage and control your manufacturing environment?
That's interesting. So do you find that people are thinking fundamentally differently now when they're looking at the future and starting planning for new transformational type projects? Are they starting from a completely different place?
Yeah, I do feel that, Steve, that this is a change in the way how people really kind of approaching the topics. I do think we had to learn that our old really kind of model came to an end almost overnight as we finally really kind of went into the COVID-19 crisis and companies were struggling for survival. I think it forced us to think more radically. I think it made it clear to us that the old world is a story of the past, but also in terms of really kind of some other elements, like, for example, digitalization. I even see that COVID-19 was probably really kind of the biggest trigger point, the biggest accelerator we could have hoped for in a certain sense, because now really kind of after what it is our months in spending in home offices instead of really kind of being at our desk in an engineering center, in a manufacturing center, out really kind of in the field, we all developed a new way in handling and using and leveraging digital technology. And I feel that that might gonna give us also that really kind of new element of new concepts, gives us really kind of all the push for trying out really kind of new things, which probably really kind of 2 years ago would have been mission impossible. So I think the virtual concept, which we all learned to adapt and we all really kind of learned to optimize for ourselves, will have a fundamental impact on the way how we're managing and the way how we're building really kind of manufacturing systems, manufacturing environments in the future as well. So in hindsight, I need to say that with all really kind of the sadness and all really kind of the tragedy around COVID-19, it probably also really kind of was the trigger point we needed to go to more radical concepts for the future.
Fantastic. Thank you, Richard. I'm glad we've had this trigger point, as you say, that's driven some more interesting transformational activity. And actually, I also welcome getting back to the old normal where we can actually meet face to face, and perhaps next time we can do this in person together. But I want to thank you again for your time. It's been a pleasure having you on the show today. Thank you, Richard.
Thank you very much.
Okay. So we've gone from Ireland to Germany. Let's continue south and go to Spain next. Our next speaker is Edmundo from Stellantis, based at their plant down there in Vigo. Stellantis was formed last year with a merger of Fiat Chrysler and PSA Group. And the new group now makes over 8 million cars annually from a really diverse set of brands, from Jeep and Ram in the US to Peugeot and Alfa Romeo here in Europe. PSA Group has been a Ubisense client for a number of years, and Edmundo wanted to share a bit about how they're using Ubisense Location Technology on their assembly line to control the use of tools. As you can imagine, it's critical to make sure the tools on the assembly line are programmed to make the correct tightening or fastening operation on each vehicle. By using the precise location of the tool to automate and error-proof these operations, it's possible to improve both productivity and quality on the assembly line. Edmundo, welcome to the event. I'll let you take over and explain in a bit more detail about how it works and what you've learned from deploying the technology.
Okay, thank you, Stephen. It's great to be here. Very pleased to meet you all. And well, with more than 60 years of activity in big up factories and efficient production center with 500,000 vehicles produced a year, this means more than 2,000 cars a day with particular high diversity of models and brands. Yes, Vigo has two assembly lines. The first line is produced in 2008, and two models of the same vehicle under two brands. 301, that's a Citroen one under the same model, and the line 2 produces all the little vans, like Peugeot Partner, Citroen Berlingo, Opel Combo, Vauxhall 2, and also Toyota Pro Ace, and the Citroen Space Tourer, that it's a family car. That's a huge amount of brands and models. And this point gets us to have a hard work in each of the two assembly lines, needing to ensure the correct operation of every tool when it's located with the correct car. In terms of tightening, with more than 500 easy tools working at a time, and before the arrival of the Ubisense technology, we used to develop some different solutions with few mechanical and some digital elements to limit the operation of the tools by that metallic plate that you can see on the floor that is detected by an inductive sensor. It's like a chain for a dog, that cuts the permission for the tool to work. With that and the photocell that we had in that bars that are all around the chariot, we can detect the car, and we have an idea of where the tool is. That is the main work for us, to know where the car is and where the tool is also. But that was inefficient in terms of balancing work, maintenance, and above all, quality and production. A lot of non-finished operations were detected by quality systems. With the Ubisense Location system, we're able today to get our tools ready just in the moment we need to, with the correct program for the car we need to work in. This meant an important improvement in the time we spent on rework due to the reduction of the number of non-finished operations. Okay, now I'm going to show you a video that it's a take on the assembly line where I show you how the system works. And well, that's me in the assembly line. Well, that chariot you see where it ports the tool. The tool is not ready to work, and there is a light, a white light that shows if the tool is ready to work. Because of the tool that it's outside the area of the car, it isn't ready. Now it must be ready. You can see the light turning on, and the tool is ready to work with the correct cycle for the correct car. Every car needs a different cycle. If I go out of the area, it's a virtual area that goes with the car. then the tool is off and you are not ready to work. That's an operation of tightening of a security belt. The green cage that you see attached to the machine, to the tool, is the Ubisense tag. And that's what the system sees as I work with a tool and with a chariot. The red point turns green where I'm inside the area. As the tool gets inside the area of the car that we need to work in, and if goes out, turns red, that means that the tool has no permission for for the operation. With Ubisense, you can work wherever you want. If you have some delay on your operation, you can be in companion of the car, and the tool is ready all the time that it's near the car. About lessons learned, our first lesson learned is probably to get sure that your objectives are clear when you install this product, because there is a lot of services that the product can give, but not all of them are useful for every situation. We were clear of our goal to improve the non-finished operations number, meaning a big improvement in time needed for the product rework. The second one is to be sure that the rest of our systems are profitable, um, because you can earn some budget taking advantage of every system that already exists. In our case, the information of the encoders that we had already gave us the position of the cars, and we saved the cost of installing Ubisense tags in every vehicle. For our future plans, if everything goes as expected, we're going to extend this type of system to the rest of the areas of the assembly lines, because everybody's very satisfied. The speed of the operations and the operators working in this assembly line is very high. It's a high gain of time for the company, for Stellantis. Well, that's the end of my presentation, and I'm very pleased to be here. Thank you all.
Edmundo, thanks very much for the presentation, and thanks for taking the time to record those great videos of you on the assembly line, showing how things work before and after you've using this solution. That's fantastic. It's great to hear as well that you managed to reuse a lot of your existing technology, and that's enabled you to profit from this implementation of the Ubisense solution there. I'm interested to know how big your team is at Vigo that have been involved in these processes and the solution that you've implemented.
Okay, the production team in Vigo that is affected for this installation is a 50 people, 50 operators team. We're talking about 28, 30 tools today that we are connecting to the Ubisense system. But the complete assembly team for the production people are almost 500 people, I think, today. And the area that we are implementing the system is a small part today. The technical assistance, the technical assistance team that I am part of is 8 to 10 people today. and we are in charge of different areas. The people involved in this project consist in one method team manager that deals with the offers and all the economic subjects. One person in contact with the external enterprises that we need to implant all the hardware and all the software solutions to adapt the system, and me that I'm the field the field technician, that coordinates all the people, all the Ubisense people with the external enterprises people in the assembly line.
Fantastic. And with that many people involved, how much time did you spend thinking about the organizational or cultural change that needed to happen as well as the technology?
Well, I think that our first contact with your technology was in 2019 through one of our main tool suppliers that I think is very well known for Ubisense, that showed us what your technology was about. Then happened our first test phase, with the first functional that we were testing the technology with testing functional in the automotive terms. It was not the definitive functional that we're using now, because we didn't know that days the advantages that we were gonna find with implementation of this system. After 1 year, we did the extension phase that went from 8 tools to the 30 tools that we are using now. So I think after all,
Edmundo, we have
2 years. Sorry.
No, that's great. I think there's a slight delay in the link, but that's great. I just noticed a quick question came in as well, asking about the precise technology you're using for the location. Can you just describe what the location technology is that you're using at the plant?
Sorry, I didn't.
There was a question just came in asking about what is the location technology you're using. I think I'm right in saying you're using ultra-wideband as the location technology.
Yeah. That's ultra-wideband, yes.
Yeah. Fantastic. Well, thanks so much, Edmundo. I look forward to working with you, obviously, as you extend it onto other lines in the future. And we look forward to obviously continuing the partnership with you down there in Vigo. Thanks very much for joining us and sharing your story.
Well, thank you, Stephen. Goodbye.
Bye. Thanks very much, Edmundo. Right. Now let's jump across the Atlantic to our next speaker. Rick joins us from Metro Transit, the transit authority for the city of Minneapolis and St. Paul's in the fine state of Minnesota. Metro Transit is another long-time customer of Ubisense, and they've been working hard on delivering improvements to the service that they offer to their citizens. What's interesting here is that these services rely on a great deal of technology to make those experiences seamless and efficient for the passengers. But once the buses return to the depot at the end of the day or when they finish their route, they need to make the tasks for their operations, maintenance, and dispatch crews seamless and efficient too. Rick is going to share the history of what they've been doing with Ubisense, about how they're tracking the real-time location and movement of buses across their depots, and how it's improved over the years and what they've learned along the way.
Thank you, Steve. I'm Rick Paulson. I work for Metro Transit. I'm a business system analyst here in St. Paul, Minneapolis, Minnesota. And we have a short video to show what Metro Transit's all about.
In 2016, Metro Transit introduced a new type of bus service called Bus Rapid Transit with the opening of the Metro A line on Snelling Avenue. Bus Rapid Transit, also called BRT, is a package of transit enhancements that adds up to a faster trip, more frequent buses, and customer amenities at the stations. First, let's look at how the service is faster than standard local service. Stations are spaced farther apart so buses make fewer stops, which helps buses stay moving more of the time. Ticket machines at stations and mobile apps allow customers to purchase tickets before boarding. Our buses communicate with traffic lights to allow them to move through intersections faster. Next, let's look at the amenities that make taking transit more comfortable and convenient. Security cameras, emergency phones, enhanced lighting, push-button heating, ticket machines that take cash or a credit card, signs showing when the next bus will arrive. Learn more at metrotransit.org/BRT.
Excellent. We have a presentation here to show our story with Ubisense. Here's an overview to show the scale of Metro Transit. We have about 81.9 million rides a year, 909 active buses that cover that. That covers about 907 square miles in our 7-county metro area, and we have about 130 routes that cover that. All right. Pre-2009, this was our system for marking up and assigning buses. Personnel would walk the garages and go out with this map and fill in bus numbers. They do it probably about 3 times a day, AM, PM, and then evening after pull-in. And you can see edits within the map, so they would have to go back and redo it because buses would move. Pullouts, we would have to assign the first row and then work our way back. And if anything changed here, this would screw up our pullout and things would get clogged up and buses would leave late. And this is just a snapshot of the day. So half hour after, we have old data. So there had to be a more efficient method. So in 2009, Metro Transit issued an RFP. 3 companies submitted bids. Ubisense was one of them. This was before my time, because I was a user of Ubisense system when I was with Trapeze, because I would show up in maintenance and go, hey, I need to find a bus. And they would show me this map that they had where the buses were. And I was like, hey, cool, you guys have a map. Ubisense was chosen because they could guarantee an accurate or more accurate positioning in the garage to keep the buses in the lane in each of the bays. So Ubisense installed their system. We started with our 5 garages that house our buses. We used battery RFID tags on all the buses. We installed sensors in all the 5 garages. And then we used GPS location from our CAD AVL system. We imported that logs from that system into Ubisense to show buses that were parked outside the garage. The first generation was not an exact replication of the garage. It was a little crude in its representation, but it did show the buses in the lane. It had colored icons that would show different statuses of the buses. Blue was a foreign bus, white was assigned, green was available, and this is what the dispatchers used to assign. And that was our map through about 2015, and then Transit Yard Manager came about, and it had more true representation of the garage. But the downfall for this was it was a slow loading map, and users would complain about that. But it did give us more business rules and a little cleaner map for the dispatchers to use in maintenance. And about this time, we added some enhancements and additions to the system. We developed hardwired tags. Our battery tags usually have issues in the winter because winters are a little harsh up here. So first cold snap in December, we'd probably have 20 tags in each bus garage go dead. And then we take time to change those out and track those buses down. Those hardwired tags, they're connected directly to the bus battery and gives us more consistent tags. Then we added an interface with Druro Hastis, our scheduling application for bus assignment. And then we also have transit stations that have gate access at Mall of America here and our international airport. We use the new Dimension 4 sensors for bus presence detection. We draw a zone, and once the bus is in there, it detects the bus, and that opens up the gate. And then we added presence detectors to our 2 other facilities for maintenance, the radio shop and overhaul base. So now we can see a bus throughout all 7 facilities. So in theory, we shouldn't lose a bus anywhere. Then about 2017, we moved into smart transit. They had more business rules, more reporting options, but the map was still slow. Green is a available bus, white is assigned. Blue is a foreign bus, meaning that it's from another garage, and for some reason it showed up at that garage. And then we were able to add red buses here, which are out of service buses with COVID. Our service was reduced and a lot of buses were stored. So anyone looking at the map knew that all the buses up there are out of service and not to use. And our present is SmartSpace. This one again has more business rules. It's much faster. It's more robust. The look and feel is the same as smart transit, so it's not a whole lot of training for users when they move to it. The downfall is our garages, we still have our original sensors from 2009. They're not compatible with SmartSpace. Here, this picture shows at our Haywood garage where the new sensors are installed. What we're doing now this week is cutting over from these old to new and configuring the garage and calibrating the new sensors to activate on the new map. And our tags on the buses are usually right here up front. Hardly any issues with them now, with them being hardwired. New projects we currently have going on. We are currently adding the new sensors to all 7 facilities. We have started with 1 garage. We implemented a new Giro Hastis interface that allows more data to be queried from Hastis and allows us to show more data on the map as far as bus status, besides just assigned and unassigned. And we're adding sensors to 2 more gates on our freeway transit stations. That's our story. Thank you, and I'd be happy to take any questions.
Rick, thanks. That was great. It's really interesting to see the evolution of what you've been working on from a very paper-based process through the early versions of hardware and software to where you are now with the latest versions of the technology. You mentioned you were previously a user of the system. How important do you think that is to get that user perspective for these types of systems? And has that changed the way that you've approached any of these projects?
I think it helped me. I kind of saw the good and the bad when I was a user. Heard the complaints, what users would say, but when I took over in 2013, I kind of had an idea of what had to be done. Our battery tags were probably the root of the cause. And we worked hard to develop a hardwired tag, and we kind of eliminated that issue.
Fantastic. And just thinking about the future things that are happening there at Metro Transit, we heard from Edmundo at Stellantis about how they're building this real mix of products down there at Vigo, and especially now including electric vehicles. I'm interested to know whether Metro Transit have any plans to electrify the fleet there, and if so, what kind of challenges that might pose for you and the team.
We have 8 now. We had some problems with them. They were grounded for a while. They had some charging issues, so they're just starting to come back online. We have a new garage going up that will house more of the electric, and Ubisense is being installed there. And we might use it for maybe driver guidance when they come in. They'll show the bus where to go. And if the charging stations are full, we can direct it to another lane, and then maybe have some type of notification when the charging station's open that they're notified this bus has to go to charging. So we're still kind of exploring that once we get our buses going here.
Okay, fantastic. Yeah, I guess the charge has become a really valuable asset, so you want to be able to utilize those as efficiently as possible. Fantastic. Well, thanks again, Rick. We're looking forward to you joining us at the end for the panel debate as well, and the panel Q&A. Just a quick reminder to the people that have tuned in, if you have any questions, use that Q&A panel. I can see it here in the studio, and I can pose those to our speakers. And obviously also we'll have some time at the end for some more Q&A as we get towards the end of the session. So we've been working with Rick and the team at Metro Transit for more than a decade. And as we move along next to our next speaker, it's another long-standing Ubisense customer. So I'm really delighted to welcome Wolfgang from Mercedes-Benz to talk about their use of Ubisense and what they've learned over the years. Wolfgang is going to share some of the innovations that they've been working on to enable the factory of the future and their experiences of deploying different location-based solutions globally to support these broad initiatives.
Hello, everybody. My name is Wolfgang Fuchs. I am working for Mercedes-Benz in the IT operations department. And there I am part of the Center of Competence for all real-time locating systems in the different kind of production and shop floor areas. Today I have the pleasure to give you an overview over where Mercedes-Benz is working together with Ubisense and using their technology, the ultra-wideband technology, for different use cases. And I will start my presentation first with a short insight into our Factory 56, which is quite famous in the meantime. Later on, I will give you an overview of how we are using the technology, the ultra-wideband technology, at Mercedes-Benz, and which use cases we are preparing and doing and realizing at the moment. I will give you some information about the challenges and lessons we have gained and experienced in the meantime. I think it's quite approximately up to 10 years, which we have experienced with Ubisense at Mercedes-Benz now. And then I will give you a short video, an excursion into our MO360 ecosystem. It's some kind of a digital platform for the future production of Mercedes-Benz, where SmartSpace, respective Ubisense ultra-wideband real-time locating system data is also a part of. And then some plans for the future. And finally, I will be happy to answer some of your questions. So then I will start with the video, please.
Automobile production of the future. What should it look like? It is sustainable. It is digital, flexible, efficient. And above all, it has people as its focus.
All this is already reality. In Factory 56 at Sindelfingen, Mercedes-Benz most modern assembly hall in its global production network. Here, a diverse range of vehicles is produced fully flexible on the same line, adjusted on market demand. At first, the S-Class sedan and long wheelbase version. Then, also the Mercedes-Maybach S-Class and the all-electric EQS. At the same time, efficiency is increasing compared to the previous S-Class assembly by 25%. This has been made possible, among other things, by wide-scale digitalization and by the flexible structure of the production process with tech lines and driverless transport systems. The two tech lines bring together all the complex plant technologies. They serve to avoid fixed points in the assembly process. Flexibility improves. When the new models are added, conversion work is easy to carry out in the other areas of the assembly hall.
Now you've had an insight into the new Factory 56, in which we produce quite most of our most important cars, like the new S-Class, the Maybach, and also the brand new EQS. Factory 56 is interesting for us here at this presentation. Why we use ultra-wideband in every production line, in all over the complete shop floor in the Factory 56. But Factory 56 is just one of many halls and facilities where we are working together with Ubisense, where we are using the ultra-wideband locationing system of Ubisense and SmartSpace. For example, alone in Sindelfingen, we have at the moment 3 facilities, 3 halls where we use the system. We have in Rastatt and Bremen, which are 2 very important other facilities in Germany, where we're using Ubisense. We are working with Ubisense and using the system in Charleston, United States, at the Vans, in AMG at Falterbach, where we produce our high performance engines. We have upcoming projects in Spain, in Berlin, and some further projects already in the pipeline. I'd just like to show you or to explain you how we use the system, how we use SmartSpace or the ACS module at Mercedes-Benz. First of all, it started all with the torque control, with the automated torque tools, and there was the initial use case when we got in contact with Ubisense around approximately 10 years ago. We started with the old S-Class, so the version 222. This actual version is 223. So we have a lot of experience with especially the torque control, automated torque tools, which is, I'd say, estimated one of the most common and well-known use cases for that system. In the meantime, the paperless factory became a very important use case at Mercedes-Benz. In early days, it is not that long ago, we had a lot of paper in the shop floors, in the facilities. We had on each car, on each body, we had a large sheet of paper with a lot of information for the workers and so on. So we had a lot of paper anywhere in the facility. And it was always an aim and target to get rid of all these paper, of all this analog information. And that is why we invented the paperless factory, where the Ubisense ultra-wideband locationing system has become a major member for this use case for the paperless factory, where we give the workers support to do their jobs, and we give them support via monitors, tablets, PDAs, or other devices where each worker can see its individual information for each car, for each job, for each task he has to do. And paperless factory got a very important use case in all over Mercedes-Benz in a collaboration with Ubisense. Another use case is the assembly control of assets in the production line. That means we are doing two things with this. That means with the ultra-wideband location, with the real-time locating system, we are giving triggers at the assembly line. For example, when the new car enters into a new station, first of all, we through the ultra-wideband location, we're giving the system or the device or the automated machine or anything, or the robot, we're giving him the trigger that now we have a new car, and then in the same time we're giving the unique identifier. So for example, in facility 56, it's an 8-digit long number, where each car is individually unique identified, and we're giving the number and the trigger, and so the machine knows there is a new car inside, and he has the unique identifier and therefore the information, and then he can get the other information he needs from any ERP systems that he's connected. and can fulfill and do his job. And we have many different assets and devices there, like refilling, refueling, measuring devices, and so on, a lot of them. Ubisense SmartSpace real-time locating information is part of the quality life application, which is part of our MO360 ecosystem platform, which I will give you in some minutes an insight, and therefore also a very important system where real-time locating system information is going into the facility, into the production, to give the workers information about real-time location of different cars, bodies, and so on, and where the workers has different jobs to do. And we have, I'd say many upcoming use cases and ideas where we could use the system. I just said the large words like big data, artificial intelligence, business information, getting more digitalized. And these are the different technologies and use cases we use at Mercedes-Benz at the moment. And we had a lot of challenges, experiences, lessons learned, of course, in the past 10 years. And I just want to tell you some about the main important points, perhaps, where I can give you some insights. First of all, it all started with quite proprietary systems, which we connected to Ubisense system. And in the meantime, we got more and more modern API-based interfaces. And it's obvious with these modern API-based interfaces, once they are implemented, finally they get cheaper, they get faster, so they get better. So it's quite easy. With modern API-based interfaces, you have quite easy, quite fast, the possibility to connect your data with other systems, to gain information everywhere where you need it. That is digitalization in life, where you can bring something forward, where you can get the efforts of these real-time locating data. Another point is the scalability of on-prem solutions versus cloud installation. At the moment, we still have on-prem installations on solid separate servers at each facility, and we are really focusing and gaining to get into the cloud. Why? It is not just we are Mercedes-Benz and we want to be modern, so we go on the cloud. No, it's the scalability factor which we have with the cloud installation, which will make it much more easier for the system, much more easier for the complete run of the system. On-prem solutions, you always have to take care of the server where the software is on it, and the server isn't growing and isn't scalable. So the company always have to take care of the servers. And with the years, you start with a use case, you have your installation and everything's running and it's fine, and you have a CPU average load of 40%. And with the years, you're gaining more and more use cases, more and more external devices, more and more systems and assets into the system. And the system is growing, but the server is staying the same. So one time you will get a level average where you reach a red line, and then we have to grow up or to change our server, and that's always a bit tricky to change the hardware in the running process. So that is one major reason why a cloud installation is getting more and more important for us. And that is also a lesson we have learned. In the future, we want to go really in that direction with cloud installation. And Ubisense told us that they can do it. They already have done it. So we are very interested in getting the first cloud installation done at Mercedes-Benz with Ubisense together. Production critical operation is always a challenge. I don't have to tell you that. Most of you will know that. But it's just a hint. Get in contact with the system, learn a lot, try a lot, do a lot of integration and tests, and you will learn the system. And once you have some experience, you will see how easy it is to run a production critical operation with the system, and it's just a fine solution. Also important was the calculation of a business case. When you didn't have any contact to Ubisense, or you want to start with Ubisense or any kind of real-time locating system, first of all, of course, you have to take some investment, some money. You need some infrastructure, you need some sensors and so on. New technology. You need people that cares about the system and so on. You're learning a lot. And you're calculating in your head, I have the system and I need it for that and that and so on. Once you have the system, you have the infrastructure installed everywhere. And then the workers itself, they get in contact with the system. They learn the system and they see, hey, we have the system. Perhaps we could do another use case. I have an idea and so on. And immediately you just need some new tags, ultra wideband tags, because the infrastructure is everywhere available, and immediately you are getting new user stories and use cases, and the worth of the system is growing and growing permanently. So that's the one important thing. Do the initial step, because new use cases will automatically follow, and it would bring you forward to the digitalization in general. Uniformity and consistency is very important. Of course, the larger your company is, the more facilities and halls you have, the more it is important to have some kind of simplified operation, common modifications, and common knowledge base where everyone can count on, and then experiences of each individual facility you can grow in one pipeline together, and which will bring everyone forward. And of course, never forget an automated and holistic monitoring, because they will protect from errors, and then you have no surprises. And also, it's fine to see that everything's running, and you have a good and automated holistic monitoring with automated news and updates, and that is a very important thing. And there you can also do a lot of, you have many possibilities there with Ubisense. Now I will give you a short insight into our ML360 platform.
Digitalization opens up entirely new possibilities for the future vehicle production at Mercedes-Benz. It is the fully digitized and paperless production that connects all production data for the first time, and it makes it available across the entire production process in real time. Simultaneously, it ensures the highest product quality. All this is enabled by MO360, the new digital ecosystem for the vehicle production. In our ultra-modern production, the vehicles are located within the production line with absolute precision. This is the basis for the needs-based information management of the paperless factory. This way, each worker receives exactly the information he needs for his next work step directly at his workplace. Internet of Things tools are integrated into the factory's local network, and they perform the checks whether all work steps have been fully and correctly completed. The workers confirm their activities digitally as well. This ensures greater efficiency and higher quality. The quality management system is fully integrated in MO360. This means that every quality manager has full access to the current life status of every single vehicle in production at any time. MO360 detects deviations and informs only the responsible employees and quality managers. With the previously collected production data, the cause of a deviation is identified straight away and corrected instantly. All applications of the digital ecosystem MO360 are fully integrated and interact seamlessly. The core of the system is the digital shop floor management application, in which all production data is merged. This allows access to a comprehensive life status of the production at any time. In everyday use, the digital shop floor management is completely convincing, both in the optimization of quality processes and as a communication tool. MO360, the new digital ecosystem for the vehicle production by Mercedes-Benz.
Digitalization, that's the slogan for the future. So what are our plans for the future in regard to Ubisense at Mercedes-Benz? First of all, as I told before, the cloud solution, the cloud installation will be the thing we will try out very, very soon, because we're very interested and keen in getting more and more involved with some cloud solutions and get rid of own unique data centers which we have on each facility. So we want to have the efforts and the positive reasons of the cloud possibilities, and that is one major aspect we will follow in the future, and we were starting with it very soon. We will go on with the next 2 steps with provision of new and additional APIs, because that brings you forward. You with the time and with many experiences, you gain more and more information and more ideas how you could use the information and the real-time data. And so it is important for us because it brings you forward to do a provision of new and additional APIs to get more and more systems connected with your real-time locating data. And that is the third aspect is research and rollout of new features and use cases that comes together. So new APIs come together automatically with new features and use cases. They strengthen them each other, so they will bring the power together, and you will use the system better and better the longer you have it, and the more intelligence you get inside of it. Exactly. And one major point is also very interesting for us, perhaps some kind of test automation and continuous updates. There we have, for example, in the facility 56, we're producing actually around the clock, so 24 hours a day. And so that means you don't have these breakdowns, or you don't have these shut-offs or long weekends where you can do and change systems and do change management stuff and so on. So you will always have, many of the time you will have a running system, and so we would be very interested in continuous updates or updates during the production time. That would be very interested for us. And we think if we all get that information, that ideas, that use cases together, we will be really succeeding to use the full potential of our real-time locating system data with Ubisense. And yeah, that was my presentation. Thank you for your attention, and perhaps I can answer some of your questions.
Wolfgang, thanks very much for that. It's great that you've packed in more than 10 years of experience into the lessons that you've learned and your plans for the future. So thanks for sharing that. One of the things I was particularly interested in, you mentioned actually right at the start around your role and what you're doing there at Mercedes, is this idea of a centre of excellence, a centralised team that's responsible for these location-based technologies. How did that come about, and is that something that you would suggest other organisations would, should look at and benefit from?
Yeah. First of all, of course, it is hard to take 10 years of experience in a 10-minute video, something like this, of course. But I try to, yeah. And to your question, yes, I am part of the Center of Competence, Center of Excellence. It's quite the same. You can call it like you want to. Some call it Center of Excellence, some Center of Competence. I think the thing is, the more diverse your company is, the larger your company is, the more important is such institution. That through such a center of competence, you have the possibility to bundle your communication, to bundle the communication from your company, so from Mercedes-Benz to Ubisense, for example. So our COC, the Center of Competence, is some kind of interface between Ubisense and Mercedes-Benz. That means we have a lot of facilities, we have a lot of different and use cases, and we have a lot of different people and in different countries and so on. And also we have old proprietary systems, we have new modern systems, we have every kind of system, of course. At Mercedes-Benz, we have a lot of systems. So it is very important that you have some kind of base layer, some common information when anybody at Mercedes-Benz or at your company wants to implement such a system, that they have some kind of place where they can go with their basic questions. What can I do? What is real-time locating? What possibilities do I have? And then we can get our combined experience from all the facilities and give them within short time great and good information. Also, the knowledge of each facility, when you have some kind of base COC. We are also the interface from the manufacturers to the IT, to the OT, and also to Ubisense. So with developing new interfaces or anything like this, we can focus on it, and we can gain the information to anybody who is interested, and we have some kind of information pipeline, so everybody has a worth of the information, and which we are separating and sparing all around Mercedes-Benz. So I'd say it's of course quite important to have such installation or such team, perhaps you could tell it.
That's great. It makes perfect sense as well when I think about the video you shared for MO360 and just the breadth of the things that you're doing within Mercedes-Benz. It makes sense to have that centralized point. The other thing that I noticed from those videos is you talked a lot about sustainability and the environmental impact and taking paper out of the factory. You talked about having a paperless factory. I can see how that would be a benefit from installing this type of technology, being more efficient and having less waste. But how important was that in the thinking before you got started? How much of a driver was that in the selection of this type of technology?
So I'd say to use something like a real-time locating system. In the first impact, it doesn't have that impact regarding sustainability or an environmental impact, but the main thing is, with this real-time locating system, with this real-time information, you are supporting the digitalization of your company, and that is the keyword of the time we have at the moment. So the digitalization is very, very important, because that is the thing where we can move forward. We can raise the efficiency of the company in our unknown manner, where we can produce faster, easier, with better quality, and these are all aspects that bring us really forward as a company, and it brings us also forward towards sustainability, because we have less waste, better quality, we are faster, we have more knowledge, more information available, and that is the thing that supports the digitalization in general, and that will bring us forward and of course support all kind of sustainability, and that finally has of course an environmental impact in general. So that's my opinion.
Fantastic. Thanks for sharing that, Wolfgang. Just one quick thing to finish. I just saw a question came in here that you talked about the connection of the MES system at Mercedes-Benz, and Edmundo shared with us the variety of models. How many different models are you making there in your Factory 56? Just to give us an idea of the complexity.
Models. So in general, we have the S-Class with about normal version, long version, the Maybach with 3 versions. We have several AMG versions of the S-Class. We have the EQS. There will come up perhaps also some kind of the E-Class in the next year also. So yeah, it's hard to count. We have a lot of different variations in general in the Factory 56. The Factory 56 was always at the very beginning prepared to have the possibility to do very, very different kind of platforms, cars, versions, long versions, short versions, and so on. So there was one of the main topics at the Factory 56 to have all possibilities and all kind of possibilities at the factory. Then to have the possibility to change anything, to remove anything, get something new, get more electrical vehicles inside the facility. That's the thing. That was one of the most important points at the very beginning of the Facility 56, which I think we could realize. And also Ubisense with the real-time locating system supports us with these different possibilities in general.
That's great. Thanks for giving that insight, Wolfgang. And yeah, so too many to count is the the takeaway I took from that. Thanks ever so much for joining us. Always great to talk to you. Okay, now we're going to move on to something a little bit different. Next up, we've got the Ubisense founder and Chief Technology Officer, Andy Ward, and our Global Head of Pre-Sales, John Heathcote. And they're going to share some of the latest developments here at Ubisense, together with some short demonstrations. So I'm joined here by Andy in the studio and John, who's connected remotely. And I'm going to resist the temptation to steal any of their thunder. I'm going to hand over straight to them to take us through their presentation.
Hi, everybody. I'd like to take the opportunity to tell you a little bit about what we're doing at Ubisense HQ in Cambridge. I'm going to talk about a new tracking tag that we have just developed, and also a new kind of sensor that allows us to detect angle of arrival and time difference of arrival from all different directions. Now, I'm going to start with the Ubi tag, which is our smallest, cheapest, and lowest power tag ever. It's also our most capable tag ever. It's a multi-mode tracking tag. It's got 3 different modes of operation. It tracks using ultra-wideband technology within the Ubisense system for the most precise positioning in the toughest environments. It also works with our partner Quipper's Bluetooth Low Energy angle of arrival system, which allows us to provide very cost-effective coverage over wide areas. And it also works as a Bluetooth beacon using either iBeacon or Eddystone technology, allowing us to interact with the tag using phones and determine presence information that way. Now, you might think that if it does all of these things, and it can actually do all of them simultaneously, that means that it's a more flexible tag, and you'd be right. So we can take a package, for example, that comes into a factory and attach one of these tags to it. And we can take that into, say, a loading bay. And in the loading bay, we may only want to know roughly where that item is. And in that particular area, we can use Bluetooth Low Energy beacon sensing using a plug-in sensor like that. They're very, very cheap, to find out where that particular parcel is to within perhaps 5 or 10 meters accuracy. And then as that package moves through the facility, maybe it moves into a warehouse where perhaps we need slightly better accuracy, perhaps a meter or 2. And there we can use exactly the same tag, transmitting Quipper signals, and use the Quipper location system to find out which particular area of the warehouse it's in. And we can also then use the same tag whilst the package is moved to line side, where there's lots of metal, it's a very challenging environment, and we need to know exactly where that particular item is, with the Ubisense system using our ultra-wideband technology to find very, very precisely where that tag is. So the same tag can be used all the way through the life cycle of a package, moving around the facility using different location modalities to get the right balance of performance and cost whilst we're tracking it. We're doing all of these things simultaneously, and you might think that that means that the battery lifetime of the tag would be compromised. Not at all. The Ubi tag is actually our longest lifetime tag for a particular size of battery, and it's actually more than 6 times the battery lifetime of competing UWB tags using similar batteries. So if we look at the battery lifetime of a tag which is transmitting ultra-wideband once a second continuously, so no cheating using accelerometers or anything like that to detect motion, something that's transmitting once a second all the time, then a UB tag will last for over 10 years in that mode. A competitive ultra-wideband tag might only last 1.5 years, so there's a big difference in the performance of the battery lifetime. If we look at the UB tag in BLE mode, it's over 13 years. And actually, we can do both of those things together, ultra-wideband and BLE, and still get nearly 8 years of battery lifetime out of a tag. So it's a very, very long-lived tag device. Now, because we're expecting these tags to be out in the environment for many, many years, we have to build them tough. And we've built the UB tag for industry. It's very compact. So the main body of the tag is about the size of the top of your thumb. It can attach to anything and it's not obtrusive. It's tough. It's a sealed unit, tested to IP69K. Nothing can get in. It will last for a very long time. We've driven cars over it. It has multiple BLE antennas, so it allows those technologies using BLE to work more effectively in tough industrial environments. And it has a magnetic button that allows us to interact with the tag by holding a magnet close to it without actually having to put any kind of brake in the case, which might let in water or similar problems. And it can be attached to all sorts of different items in lots of different ways. So we can use tie wraps, we can use screws, we can glue it to things. It even comes in different form factors where we don't have the mounting lugs, we've just got the main body, and as a watch type form factor that allows it to be used for tracking personnel. It's also the lowest total cost of ownership tag that we can see out there. So if we look at an ultra-wideband application where we're using a tag for about 5 years, tracking it twice a second continuously, which might be the kind of level of performance we're looking for in a factory, the UB tag is cheaper than competitive ultra-wideband tags right from the get-go. But because we've got such a long battery lifetime, we also win in terms of the total cost of ownership. For that 5-year battery lifetime, the UB tag has got enough battery lifetime to get us through to the end with the battery that it had on day one. But that competitive tag needs its battery replacing roughly every year. So every year we have to pay for a new battery, and we also have to pay for the cost of going and finding that tag and bringing it back, changing the battery and putting it out there again. Now we've talked to our customers, and that cost can be anywhere from $10 to $80 each time a battery change or battery recharge cycle is taken into account. Here I've assumed that it's at the low end of that scale. But by the time we've done that 5 times, you can see that the total cost of ownership of that tag over the 5-year period is more than 3 times the total cost of ownership of the UB tag. And we can do a similar calculation in the BLE space. So although the UB tag is more expensive than competing BLE tags, they're extremely cheap, made in very, very high volumes, but they also have very, very small batteries. So the UB tag probably lasts about 3 times as long as one of those other tags. And again, by the time you've considered taking that tag, bringing it back, changing it for another one, these BLE tags tend to have sealed batteries. By the time you've done that a few times, the total cost of ownership of the UB tag is about half that of the competitive BLE technology. So not only is it our most capable tag, it's also the lowest cost of ownership tag. Looking at the infrastructure side of things, we've introduced a new omnidirectional sensor. So our sensors are quite special in the ultra-wideband world in that we measure both time difference of arrival, the time of arrival of the signal coming from a tag at a sensor, but we also measure 2-axis angle of arrival. So we measure an azimuth and an elevation angle for that incoming signal. And that lets us find the position of a tag using only information from 2 sensors. But our previous sensors were directional, so they tended to be placed on a wall, looking into a space and cover a certain sector of the field of view that they were looking into. Our new omnidirectional sensor can be placed in the ceiling, looking down, and it has an essentially hemispherical field of view, so it makes it much more cost-effective to cover large spaces. I've got an example here. If we take this map and we say, what does it take to cover this with sensors? Well, if we use standard Ubisense sensors and place them in the middle of the space, each one would cover a certain field of view. And we'd have to connect that via cabling to a PoE switch, a power over Ethernet switch, and a switch cabinet using Cat5 cable. And obviously, if we want to cover large areas, we have to tile these fields of view so that the whole area is covered, and that involves a lot more cabling, more switches, and so on. But if we do the same thing using Omni sensors, we can do it much more cost effectively. We can do it with fewer sensors, fewer cables, fewer switches, and the total time to value is much reduced. So I'm going to hand over now to my colleague John Heathcote, who's going to show you some of these new technologies in action.
Thanks for that introduction, Andy. So let's now take a look at how we can put some of those technologies into action and solve some real customer problems with Ubisense's SmartSpace platform. Let's take a look at a typical manufacturing environment. Here we can see a SmartSpace digital twin of a customer production environment. And in this particular environment, what the customer is interested in is ensuring that the right materials, which are depicted by these blue pallets with stacked goods, are being delivered to the right locations in the material flow process at the right time. This is a really common problem, and many customers that we engage with are looking to move away from traditional manual bookings into their ERP system using things like barcode scanners, because being manual, those processes can be both error-prone and timely. So what we have in SmartSpace is this ability to geometrically model the production environment and also build a spatial model that represents all the interesting areas, in this case, of the material flow process. And so, what we can see as material flows from the warehouse to various downstream storage locations, and eventually what we can see over here, these are line-side consumption points. We have smaller and smaller footprints for material to be located, in which and therefore more stringent requirements in order to register material arrival in each of those locations. So this implies an increasing level of location accuracy requirement for materials that are arriving at each of these locations. And this is therefore a great example of what can be achieved with a multimodal tracking system using the UbiTag that Andy's introduced and Ubisense Omni sensors. So in this area here, where we can see we've got fairly small zone requirements, we can achieve wide area coverage across these line feed locations and these nearby storage buffers with Ubisense Omni sensors. And they will allow us to track this material with pinpoint accuracy to guarantee the correct association between those materials and the various control points in the material flow process. So you can actually see an example right here. If I get this pallet over here to move into one of these line feed locations, you can see that this pallet is now being tracked to around 15 centimeters accuracy, and we get a highly reliable spatial trigger as that material arrives into this tightly defined line feed location. If we now zoom out and shift over to the warehouse as another example, what we can see here is pallets are stored in a fairly large area, and the spatial zone that represents the warehouse is much bigger. By way of comparison, we can see that the required location accuracy to confirm materials inside the warehouse is much lower. In fact, what we can see here is a pallet that's being tracked also with the UbiTag, but in this case, we're using a lower cost, angle of arrival based Bluetooth low energy real-time location system with a typical accuracy of about 1.5 meters. And that would be perfectly acceptable for confirming and asserting that materials are located in this warehouse, and also going and finding those materials if needed using a map. So in so doing, we're able to use the best of multimodal sensing capabilities to achieve reliable location data everywhere in the material flow process. So let's now switch over to see how that material flow information can manifest itself inside SmartSpace and be consumed by business users on the shop floor. So here you can see a simple overview dashboard built using SmartSpace of all our material status information. We can see exactly where we have material shortages. In this case, we can see our line feed locations are all lacking material availability. And we can also, using SmartSpace's process logic capabilities, build things like prioritization capabilities that tell the fulfillment team where materials are required the most urgently. We can see in real time where all of our pallets and materials are located, and we can see those movements happening in real time on the map. Let's say I wanted to request that one of these pallets moves down to line feed number 2. I can immediately move that pallet to line feed 2. And we'll see in real time as that pallet arrives, our line feed 2 material increments and the amount of material we've got at various locations changes as well. And the priorities for our fulfillment have changed because line feed 2 is no longer lacking materials. Now we can head back to Andy to get some more exciting product updates.
Thanks, John. Now I'd like to talk a little bit about how we go about deploying our systems. The stages in which we deploy are typically split into 4 components. First of all, we'll go and survey a particular site that a customer has invited us on to take a look at. And that's really about understanding site environment and the application that the customer wants us to implement. Once we've done that, then we can start planning the sensor system that supports that application. And that's really got 2 areas. We look at the sensor layout, work out where the sensors might be placed and so on, what fields of view they have, and then check that will provide coverage that's acceptable in terms of application performance and so on. Then we'll go on to install the sensor system, and that involves placing cabling to support those sensors and actually physically installing the sensors themselves. And finally, we'll calibrate the system. That means surveying where the sensors are placed and orientating the sensors and so on, and then checking that the system is working properly and meeting the performance requirements that we originally set out. So our aim in development is to try and improve the time to value here for the customer as much as possible by shortening these areas as much as we can. So if we look at the environment capture area, the survey, the way that this used to be done is that people would come to us with a floor plan for a facility, and we'd try and work out from that where we might place sensors, where in those areas the sensors could see, and so on. The problem was that no floor plan that is in existence for any building is exactly right, and it doesn't really tell you much about how the building's being used. So we get rid of that, and nowadays what we do is we use laser scanner technology. So this is one of our employees carrying a laser scanner in his hand. It's got a sort of backpack-mounted data capture utility, and what that generates is a point cloud, a bit like this one, which shows a kind of indoor 3D picture of exactly where everything is in a factory so that we can understand how the factory is set up. Now, the point cloud by itself isn't tremendously useful, but we have tools that turn that point cloud into a 3D model with walls and equipment and so on. And we can use that model in lots of ways to then improve the subsequent stages of our installation. So we can take that model, for example, and in the next stage, planning the sensor system, work out where the optimal place is and the optimal number of sensors are going to be. We can take the model and place virtual sensors inside it and see exactly how they're going to be obstructed by items in the factory, walls, equipment, and so on, and add and remove sensors until we've got exactly the right balance of performance and cost for the particular customer. So if we see, for example, on this heat map that there's an area that's shadowed by a set of machines, for example, and we need to place another sensor in, then we can do that virtually before anybody has gone to pull cables out and so on. Once we've got an optimal sensor plan, then what we can do is we can work out whether the performance of the sensor system is really going to match the application requirements. We can send virtual tags into the space and use exactly the same algorithms that we'll use in the final sensor system to analyze signals, virtual signals sent from those virtual tags to our virtual sensors and check to see what the performance of the system is at any point in that space. So here, for example, if you look at the bottom right, you can see that the tag is predicted to be accurate to at least to most 0.1 meters at that particular point in space. So it's pretty good there, and we're pretty sure that the sensor system is going to work well in that particular place. Now, at that point, we know where the sensors are going to be, and so we can go and pull the cables to those points and install sensors at those places. At that point, we need to do our calibration. Now, the traditional way of doing that was using what's called a laser total station. This is a kind of piece of surveying equipment, and it allows us to find exactly where those sensors are in a facility to within a couple of centimeters accuracy. And we need to do that because if we want to get centimeter level ultra-wideband positioning out at the end of the day, then we need to know where our sensors are to a similar level of accuracy. The problem with these things is that they're quite cumbersome and time-consuming to use. So again, we can get rid of that and go back to our laser scanning technology that we described earlier. We use this LiDAR scanner, but this time we place a Ubisense tag on it. You can see it just above the orange curved top of the laser scanner there. And what we do then is we take a map of exactly, we walk around the facility again, and that gives us a trace of exactly where the laser scanner has passed. And at the same time, we're measuring signals from the Ubisense system. And we marry those two pieces of information up. The laser scanner lets us work out exactly where the sensors are, exactly what orientation they're in, and it automatically self-calibrates the system. So this patent-pending technology allows us to calibrate even the most complex location systems in the time it takes to walk around the facility. This here is an example of a calibration that we did at a car assembly line. And it's actually got two traces on there, although it's very hard to see the difference between them. The dark blue trace is the path that the scanner walks around the facility, and the light blue trace is the results that we got from the Ubisense system after it has automatically calibrated itself from that scanner run. And the fact that you can't really see those two traces as distinct means that the accuracy of the system is incredibly high there. In fact, the accuracy of auto-calibration is higher than the manual approach that we used to use. So we've actually been using this over the last couple of months in some of the biggest deployments that we've been doing over that time. And it's really proving benefits. So for example, we've done a large car assembly plant using this technology in the US. And that's important because car plants run pretty much 24/7. You get very, very small breaks in which you can install and calibrate a system. So time to value there is all dependent on being able to get in, install the system, calibrate it, and get out. Similarly, we did a large US bus depot, and the trick there is being able to do that whilst buses are driving around at high speed through the depot doing their normal runs and so on. And again, the ability to be able to do this in just a couple of hours across this huge bus depot really was beneficial for our team in the US and for the customer as well. We've also been using it in the UK. So we've installed a pop-up eye clinic at a shopping centre in London using this technology. And again, time to value is important for these guys because, of course, it's a pop-up clinic. It's meant to be quick and easy to install the system to support what's a potentially temporary installation that has to be installed very, very quickly. And we did the same thing at a national security site in the UK as well. Here, the challenge really was that the people running that site don't want us on site. They don't really want anything to slow down their operations or for anybody to really be interacting with that site at all. So the auto calibration allowed us to get in, do the calibration, and get out as quickly as we possibly could. And of course, the customer is very happy about that. So John is going to show you a few more examples of these tools in action so you can see exactly how they work yourself.
Thanks, Andy. So what I'm going to show you now is a brief introduction to our new Dimension 4 Sensor Planner tool, which is going to make system planning fundamentally easier and more reliable for anyone who's working with the Dimension 4 system. And the first thing you'll see here is that we have automatically generated a three-dimensional model out of a point cloud generated with one of the approved handheld mobile LiDAR devices that Ubisense has been designing around. And what you'll see here in this model is that we've captured an awful lot of the structure of the building that we've walked around with the device. Now, in order to use the auto-generated model that you can see here to perform sensor planning, what we need to do is focus in on the area that we want to do our sensor planning design around. And so what we can do with this model is that we can take, in this case, all the high elevation and roof details off, so we can see inside the building where we want to do or create our sensor plan. So now you can see we've got a full site model where we can do or create a sensor plan and analyze sensor system performance in any of the required tracking areas for the customer. So let's take a look now at what it means to actually build a sensor plan and look at sensor system performance. So let's start by taking a look at this little room area over here. All we need to do with the sensor planner is to decide what type of sensor we want to deploy and drag it into the environment. So if I come up onto the top left over here, where we've got sensor, and drag one of these down into the environment, the system is smart enough, if I drop it near this wall, to know that I'm wanting to snap that sensor to that surface, which represents a wall structural surface in the environment. So if we now want to reorient that sensor to make it point into a different part of the environment, we literally just shift-click into the model, and that makes the sensor point at where our mouse is located. Let's go ahead and start dragging a couple more sensors into the environment. So we can see what a more general coverage area looks like with the sensor planner tool. So a couple more onto this corner here. And one last one in our final corner. So what we end up with once we've done that is this blue colored, almost like a heat map that is spread out across the building space. And the blue color and the depth of the blue color gives us this indication of the amount of tracking coverage and confidence in the tracking that we'll get in each of those areas. So a darker or deeper blue color represents a high degree of confidence and reliability in our tracking. And as the color fades off into lighter blue and eventually white, that is a decreasing level of coverage, and white basically means that we've got no sensor coverage in that area. Now, the coverage map that we have is planar, and so we can come over here and actually adjust the height of the coverage map. And then the system recomputes the coverage, taking those new structural characteristics of the model into account, And you can see now the amount of blue that we've got in our coverage map has reduced. So you can see, for example, over here where we are behind a desk, the sensor system at that height wouldn't be able to see, behind the desk through the structure of the occluding desk. So the model takes all of those structural complexities into account when we're working out this coverage map. So the last thing I want to quickly show you is we switch now to a site-wide view, and I bring in a model that I have prepared earlier where I have deployed sensors all over the environment to give you an idea of what a full coverage map looks like. I'm going to apply some default values to all of my sensors that are in this sensor plan and recalculate the coverage across the site. If we can see we've got lots of sensors across the site now. The system is now computing all that coverage heat map, and as that starts to get filled in, now you can see across an entire facility, and this could be as big a facility as you like. You get this bird's eye view of the quality of your coverage for all the sensors that you have placed into the environment. So that's all from me, and back over to you, Andy.
Thanks, John. Whilst we were watching John's demonstration, a question came in which asked whether we could periodically do that same calibration task in a factory after the system's been installed and has been running for some time. And the answer is absolutely yes, we can. That's a really good idea as part of a periodic maintenance to check that the calibration of the system is still as good as it was on day one, because as we all know, factories are dynamic places, things get bumped all the time. It's really important to make sure that those things happen. Now, we've got lots of health monitoring, as Wolfgang from Daimler mentioned earlier, that tell us about what's happening in a factory, but that kind of periodic health check is not a bad thing to be doing with any large-scale location system. So the last thing I'd like to talk about is outdoor centimetre level positioning. Obviously indoors with technologies like ultra-wideband, we can track extremely precisely. Also obviously we've done an awful lot of work outdoors with technologies like GPS. And of course, everybody understands how GPS works these days. We have a mobile device, some satellites, and we measure some signals from those satellites at the mobile device to find out where it is. In principle, that's extremely accurate. But actually, in practice, the accuracy of something like GPS, standard GPS, is maybe in the 5 to 10 meter range due to signal errors that are introduced by passage through the ionosphere of the Earth. And that limits the applications that we can use GPS technology for outdoors. It's a great technology, it's very, very low infrastructure, but it's just not that accurate for some of the things that we're doing. So we've been interested in how we can do centimetre level positioning outdoors, and a new technology called RTK GPS is something that we think is very interesting. So the way that RTK GPS works is it layers a whole bunch of technologies on top of each other to get fantastic outdoor accuracy. So the first thing it does is it uses what are called carrier phase techniques, where it looks very, very carefully at the incoming signals from GPS satellites to essentially count how many wavelengths of signal there are between the mobile device and the satellites. And that gives us some extra information about where the mobile device is. It also uses what are called differential techniques. So it uses a reference base station that's placed somewhere near to where you're trying to track the objects. Perhaps it's a fixed area of the factory, a particular base station that's placed in the factory somewhere. And what it does is it looks at the same satellites from the same signals from the same satellites passing through the same part of the ionosphere, and it looks at the errors that have been introduced into that reference base station location by the passage through the ionosphere. And we send those observations as corrections to the mobile device, which subtracts them, and then hopefully we get a more accurate measurement of the satellite signals. As it happens, each satellite also transmits multiple different frequencies. There are military frequencies that we can use and so on. And so now in RTK GPS, we use those as well. And then finally, there are lots and lots of different kinds of global navigation satellite out there now. So there's a GLONASS system, which is Russian. There's the Galileo system, which is European. And there's the Beidou system, which is Chinese. And all of these systems transmit signals that we can actually receive at both our base station and our mobile device to figure out exactly where that mobile device is. Now, the difference is really along the lines of, rather than measuring, say, 8 signals at our mobile device, now we're measuring about 60. And that increase in the number of signals that we're measuring, the amount of information that we've got, and the ability to use differential techniques means that we can get incredibly accurate positioning. So the kind of performance that we see is shown here. So these are 2 examples where I took an RTK unit around our parking lot here in Cambridge. I walked around my car, and you can see clearly the path as I walk around the open door of my car. And then what I tried to do is I tried to trace the parking lot number that's on the floor. You can see the scale roughly against my hand there, and it's very, very accurate. You might say, why has it got a star at the bottom rather than a 0? And the reason is because we're only getting 1 update per second, and I was moving the tag around that 0 too fast. But all of the points on that star are on the 0. I can really guarantee that it's accurate to about 1 centimetre. This is the kind of thing, though, that we're going to be using it for. So this is an example where we took a car, equipped it with an RTK GPS unit, and drove around our parking lot. And you can see exactly which parking bay we were in at any time. And the amount of infrastructure required to do this was 1 receiver. So this is an entire car parking yard covered using 1 receiver, and with centimetre level accuracy everywhere. So we're taking that technology and combining it with ultra-wideband to allow seamless indoor and outdoor tracking. Indoors, that tag will use traditional ultra-wideband technology from Ubisense, accurate to a few centimetres. Outdoors, it will use RTK GPS techniques and figure out where it is, and then send that information back to the Ubisense SmartSpace software, either over a local area or a wide area or a cellular network. Now, there's got to be a downside to this. The downside is simply power. So GPS is quite a power-hungry technology, and therefore when we're using RTK GPS, we have to be powered by a piece of host equipment. So this isn't something that we'll be placing on large numbers of pallets or large numbers of items that are stored in an area. Rather, what we would be doing is tracking things like the forklift used to move those particular items, or perhaps cranes, or perhaps people using smartphones, those kind of things. This technology is already being used by Ubisense in customer trials, and it's going very well. And we see lots and lots of applications for this in the future. So we see, for example, things like forklifts tracking items that are being placed indoors and then taken outdoors and stored in storage yards. That's a perfect example for using RTK GPS. We have a power source. We can even work out the orientation of the forklift by putting 2 of these units on and seeing how they move relative to each other. The same kind of technology can be used in these enormous yards. This is an example of a wind turbine factory in the US. And the same technology allows us to get centimetre level positioning of all of these items, and also their orientation if we can track multiple points on them using either multiple different pickup units or multiple forklifts across an entire space like that using just 1 or 2 base stations. So it's very, very low in terms of infrastructure cost. And we can use the same technology as well for safety of life applications like trying to make sure that people don't wander during rail maintenance onto live rails. Here, the accuracy really is important. You've got to be able to tell between this rail, which is live, and the one next to it, which is not, and this technology allows you to do that. So at this point, what I'm going to do is hand over to John, who's going to describe another use for this mixed indoor and outdoor centimetre level precision.
Thanks, Andy. So I'm really excited to show you this demonstration. This RTK GPS capability combined with ultra-wideband truly does give a next level capability around indoor and outdoor high accuracy tracking. What you can see in this SmartSpace demonstration here is a large bus depot where we have a high population of buses being tracked indoors and outdoors. And the first thing you'll notice is how cleanly snapped all the buses are to specific bays in the yard and specific lanes inside the bus depot, ready for pull-out on the next shift. And with that high accuracy location that we now have both indoors and outdoors, we can very reliably manage both the buses and our space utilization in the yard. So we can see for every single bus lane exactly which lanes are occupied and how many buses we have in there right now. And we can also see with a very high degree of confidence which bays in the yard are currently occupied and which buses are in those bays right now. The other thing that this model now tells us, being able to track seamlessly indoors and outdoors, is exactly what process areas our buses are in right now. And while we have yard storage for buses, particularly buses requiring maintenance, we also have our indoor lanes ready for next morning pullouts. And we also have various wash, fueling, and maintenance areas. And so SmartSpace gives us a lot of detail about exactly what process and step our buses are in right now in our depot. So we've got an awful lot of valuable underlying data in this SmartSpace digital twin. And like with many other SmartSpace applications, we can deliver that information to end users in custom web user interfaces that not only tell you where your assets are located, but also an awful lot of valuable status information. So here we have a live web map view of our depot, and our buses are color-coded to indicate their current status. In this case, the color of the bus indicates the current maintenance level of the bus and its readiness to be allocated to the next round of pullouts. So if I go and click on any particular bus, I can see a bunch of information pulled from our depot management system that is now easily visualized against the bus in SmartSpace about the status of that bus. And I can see buses requiring maintenance, what's wrong with them right now, and I can click into those buses and get more useful information. What's great about this as well is I can use this web interface for managing data on our buses as well. So let's say I wanted to allocate one of these buses to a particular route. I can now zoom in, find one of my green buses, find one that's available, and as soon as I allocate that to a particular route, the status of that bus will automatically update. SmartSpace automatically changes that bus's appearance so that everybody knows that that bus has been allocated to a route, and I can see what route it's due to go on and when it's due for pullout. The SmartSpace web map gives us many different ways of visualizing our asset information, in this case, the status information of our buses. We can also see down the bottom here, we have a large collection of buses awaiting maintenance. So as can be seen, SmartSpace, and particularly SmartSpace combined with these seamless indoor-outdoor tracking capabilities, gives depot managers the ability to visualize in a highly reliable way exactly where all their buses are and gain a bird's eye view of the status of all buses across the yard at any time. Thanks, and back over to you, Andy.
Thanks, John. Steve, did we have any questions during?
Thanks, Andy. Yeah, we do. We have. We've got quite a few, but I'll ask you a quick one. Someone asking about the Omni sensor, about the range of the Omni sensor, as in, what sort of ceiling height is appropriate for that product.
So the range is in the sort of 30 to 40 meter distance. The ceiling height that we've used it on typically so far has been up to about 5 meters, but I think it could go quite a bit further than that. But obviously, at some level, you start using the range to get from the sensor in the ceiling down to the floor rather than out and covering an area. So, that's something that we'd look at, with a customer regarding their particular site.
Fantastic. Thanks, Andy. It sounds like that's a challenge for the person that's asked the question. We'll find out precisely just how high that ceiling is that we can mount it on. Thanks so much for your questions. A reminder just to submit them into the panel when you get the chance. Okay, let's now go to our final speaker of the day, Lauren from Collins Aerospace. Lauren has kindly offered to talk about their project, and it's interesting because unlike some of the other speakers we've had today, Collins is really at the start of their journey with Ubisense. Using a combination of our SmartSpace software and RFID tracking. I'm looking forward to hearing about the project they're embarking on at both their sites in Germany and the US, and what kind of advice they would give to other organizations starting out on their own real-time location project.
Hello, it's good to be here with you today. As you saw, my name is Lauren DiBlasi, and I'm the Digital Operations and Continuous Improvement Manager at the Hamburg location for Collins Aerospace. At our location, we work exclusively on the A320neo. It's a mid-size commercial Airbus. And what we do is we install the engine buildup, which is about 500 smaller to mid-size parts onto the engine, which then allows it to be attached to and hooked up to the airplane. And we also go ahead and paint the nacelle components, which are the large components around the engine. So if you're not familiar with aerospace manufacturing, I always say the nacelle is what you see on the engine. So when you're on your vacation, in the aircraft looking at the engine, you're actually looking at the nacelle. You're not seeing much of the engine at all because that's what's inside. So my position is pretty fun, I think, because I get to work on bringing digitalization projects to the site. For a few years now, we've been talking about an RFID solution at Collins Aerospace, and we piloted a small project at another facility. And one of the lessons learned from that pilot was that we really want a solution that's going to be integrated with SAP. SAP is our system of record at the site. It's for finance, for inventory, for everything. And we've been using it for decades. And we really want a inventory management solution to be connected to it. So when they launched this project of a second pilot with a solution that was integrated to SAP, we were really lucky in Hamburg because they decided to choose Hamburg as the site for that project. And so since then, I've been trying my best to learn about RFID technology, and so is the site. And luckily, we've had Ubisense with us to patiently explain to us the technology we really knew nothing about from the beginning. But our use case is pretty simple, in fact. Like I mentioned, we have a global supply chain. Most of those major components, those big nacelle components, are coming from another factory of ours in the US, and they're being shipped over to us where we paint them. The smaller components for the engines are coming from a variety of suppliers across the world. So all of these things are coming to us at our third-party logistics company. And so there, it's an offsite warehouse where they will do the customs clearance, they perform the receiving in SAP, they perform the storage, and ultimately what they're doing, especially with those engine parts, is they're kitting them. So those 500 parts go into these individual shadow boards. So one kit can be delivered to our facility just in time for the build, and the operator has exactly what they need for that one unit that they're building. So when we started the project, we were thinking about some of the most important requirements we had for the RFID technology. And one of the main ones was to improve our ability to identify large parts. So those big nacelle components arrive to us in some pretty large boxes, and we're able to stack them, two on top of one another. So when you're standing on the ground and you're looking up at these two components, it's basically the size of a two-story building. And if you want to know what's inside the component on the top, the serial number and all the information about that, you're largely dependent on what paper signage might have been attached to it and how it was positioned against the wall, if you can even see that signage. So we wanted the ability to be able to scan that box and know which serial number it is and which component it is exactly. The other thing we wanted was to automate some of the SAP inventory movements. So today, our process is largely manual for SAP inventory movements. And to be honest, we have some wireless devices, but the users and the material handlers don't like using the interface so much. It's not very user-friendly, and they actually prefer to go to their desk in most cases to transact the SAP movement on the computer. So we really wanted a user-friendly interface or an automated interface that was going to allow us to align the physical movement with the SAP movement. So we're getting more accurate data. Besides the fact that automating the inventory movement is just eliminating an entire section of waste in the business. The third thing we wanted to do was to be able to track the parts that were in transit from our 3PL to our site. Because our 3PL is located off-site, we didn't have a good way of knowing what had left their facility and what was on its way to our facility. And while we do have, tacted logistics and things like that in place, there's always ad hoc requests, and it's always good to be sure and be able to manage and monitor where your parts are in transit. And lastly, we really wanted a solution that was going to help us with our inventory management. We have the requirement to double check our inventory and therefore count all of the parts we have at least once a year. So we divide that up into monthly buckets of counting parts and validating inventory. And you can imagine when you have, a box of parts that might be 500 bolts, you're very subject to human error. And we really wanted a way that RFID could help us to possibly scan the bins and scan the tags and tell us digitally how much was there rather than relying on a human to count every single part. So really quickly, I'm just going to walk through, like Stephen said, we're in the process of development, so I don't really have anything to show you that's been deployed yet. We're still in the process of installing the hardware and things like that. But the general flow of material will be through the 3PL warehouse, where it goes to a receiving area. We're installing a RFID table reader, so the user can unpack the goods, perform the goods receipt in SAP automatically with the RFID label printing. When they attach that label, they will then be able to store it into the supermarket. And we had Ubisense design a better HMI, so a handheld interface that's more user-friendly, where the operator can take it with them into the supermarket, and it will organize their route through the supermarket to make a more optimal way of taking the parts from receiving and storing them into the supermarket, along with also pushing the transaction to SAP, where now the part is actually on the shelf. We've also designed another HMI, which helps with the kitting process. So the user will go into the supermarket aisle with their handheld and be able to know where to select the parts they need to kit the different shadow boards. And as they're picking up the parts and putting them into the shadow board, they're able to issue those parts directly to the production order. From the SmartSpace HMI, they can also store that production order when the kit is complete and it automatically performs the SAP stocking movement. So finally, when everything's been kitted, when everything's ready to be delivered to our site, the users can take the parts from the various areas and they'll go through an RFID gate at the outgoing door, and that will trigger an alert that these parts are now in transit and on their way to our facility. Once they come to our facility, they go temporarily to our logistics warehouse where we have a Kanban in place. We are installing an RFID gate there to basically end the in-transit status of the parts. Now they're received at our facility. We no longer have to have those forklift operators and material handlers going to their desk to make the inventory movement in SAP. It'll be done automatically once it goes through the gates. And then finally, when the parts are ready to be delivered to production, they'll go straight to the production floor and go through another set of gates where they will then be taken out of inventory in SAP and issued to this next assembly whip. So we installed a lot of gates here to help with that automated movement of material while still using SAP as our system of record. And I wanted to give some key lessons learned from our development process, because we did learn a lot. You know, we developed this solution from nothing into what you just saw today. And I think the biggest takeaway is details. There were many cases where, we didn't think something was super relevant, or we didn't go far enough into the details on something, and then it came back at us later, you know, where we had to go back and rethink. So I think some of the ways that we could have avoided missing some of those details was first to, you know, empower the people. So we had, you know, a huge team from people in the US to France and Germany helping on this project. But at the end of the day, the project is intended to help the material handlers, and it's supposed to make their lives easier. And so including them in the project really made a difference, because they're the ones who are actually doing the work and they know what's going to be helpful. So encouraging them to speak up and participate in the development meetings was a big benefit. And we had a lot of aha moments whenever we included them. Another thing was, unfortunately, for our project, it just got kicked off during the start of COVID. So we had to be very creative with Zoom, and being visual was a big benefit for us. You know, in a lot of cases, our meetings involved, 30 people. And so keeping 30 people engaged on a weekly meeting is a real challenge. So having visuals that are tracking the right things, able to convey the right things during those Zoom meetings makes it much easier. Also, our team was very international, and so visuals just at the end of the day can be much easier to understand when, maybe you're even balancing lots of different projects, you're thinking in different languages in your head than what you're speaking. So visuals can be so much easier to convey the message. And the last thing was just to be thorough, like I sort of alluded to earlier, documenting all of the processes, including the exception cases, and mapping them out is really a lesson learned for us, because there were some cases where we thought, that's an exception to our main process. And so we're not going to think about that right now. We'll take care of that later. But, at the end of the day, it would have been easier to take care of it at the beginning, because maybe, we found out that it was not as much of an exception as I thought, and it's actually occurring more than I originally anticipated. So looking at all of your processes and developing a solution for all of your processes is definitely recommended, along with not making any assumptions. Everybody on the team was coming from a different area. Maybe we never met each other. A lot of people had never even visited the Hamburg facility. Maybe they never even knew what a nacelle was, because we were working with a lot of people from the IT department too. So just not making any assumptions about what people know about the process, what they know about the product, really helps, to be sure that we get the details through to everybody and everybody is understanding what we're doing. So with that, I wish anyone success on their journey as they develop a solution for RFID or with Ubisense.
Great. Thanks very much, Lauren. You talked at the start about this being a fun project. I suspect it's also pretty frantic as well. So thanks for taking the time to share with us today. I just want to pick up on a thought you left us with at the end there. You talked about being inclusive, getting people involved, and being able to generate those aha moments when people speak up and contribute something as part of the team. Do you have any examples of the type of thing that came out of those sessions?
Yeah, definitely. We had conducted one site survey, which was late at night and didn't really involve the logistics team too much. And so it led us to originally assume that we needed a RFID table reader in the kitting area, because we thought that all of the pickers were going through the supermarket, picking the parts, and then bringing them to the area to put them in the shadow board. So we had gone forward assuming we needed this kitting table. But then during our second site survey, where we included a lot more of the logistics team members, we realized, oh, wait, they are actually doing the kitting in the shadow boards directly in the supermarket. And we don't need this kitting table at all. In fact, they wouldn't use it if we installed it. So it was really good to have known that and corrected before we went ahead with the design. And now we developed an HMI in the handheld units that can help with the pickers.
That's great. So what you think is a process isn't necessarily what the process is. These things have a life of their own, I guess, and evolve over time.
Mm-hmm.
Fantastic. Well, thank you very much, Lauren. What I'd like to do now is invite back some of our other speakers for a quick panel Q&A. I've been having some questions come through here. So through the magic of television and Zoom, hopefully we should be able to get back Edmundo, Rick, Wolfgang and Andy to join Lauren and I here in the studio. I can see everybody. That's fantastic. Thanks for joining and coming back for the questions. So I'm going to do these in no particular order, but Andy, I want to start with you just because we've got a really nice question here. We've talked about some different types of sensing technology today, and what someone's asked here is, what's the best? How do you know what the best sensor is for the job? Can you give us a very quick insight into how you would determine that?
It's a great question. I mean, obviously, there's a very wide range of sensors covering, they've got different price, performance, constraints, all those kind of different elements. I mean, there's part of it which is just having experience of those over a long period of time allows us at Ubisense to work with clients and understand what the real requirements of their application are and find that best sensor that's got that. Typically it's a price performance kind of issue, and you're searching for the smallest number of sensors that will cover all of the application requirements without getting into a corner where you're making a sensor do something it's simply not capable of doing. There's no one-size-fits-all answer to the question, but it really is just, I think, a matter of experience and knowing the pros and cons of each different technology, and understanding in detail what the customer is trying to achieve, and then finding the right technology mix for that. So it's a pretty broad question, but a pretty broad answer as well.
No, that's great. I think we've, one of the things we've demonstrated with our guests here is they've each had a different use case, and therefore they've had to look at something different in terms of technology. Thanks, Andy. So quick question here. Was there, actually this is about integration, so maybe Lauren, I'll start with you and come to you, Wolfgang. The question here is, how easy was it to integrate with SAP? And I guess that's a question we could probably level at pretty much any large enterprise application. So can you give us any experience so far about how it's been integrating with big applications?
Yes, so I can only advise on the development side, but I will say that was actually one of the most challenging for us because Collins Aerospace is a large company. They have a large digital technologies team in the US that none of us had ever met before or knew before, and it's such a kind of a gorilla to wrestle. So I think that was probably the most challenging aspect, but I think it's one of the most essential aspects. So if, in a way, it was a kind of the first time we've done something like this before. So I'm hoping that after this first time of integrating with SAP, subsequent integrations with other programs or additional software will be easier.
Fantastic. Thanks, Lauren. And Wolfgang, perhaps I can ask you, there was a specific question here about integrating with manufacturing execution systems, which I guess, notoriously, they're all very different and a lot of them are quite often bespoke. What were your experiences of integrating with different applications?
Different applications. We still have a lot of proprietary applications sometimes. So therefore, it was a specific development together with Ubisense. So it wasn't a problem at all. The thing is, if you have to connect several systems together. So we don't have just a Ubisense with one system and then Ubisense with another system. Sometimes we have 3 or 4 systems in a row or in a circle, and there you have several challenges to connect each system with each other and to have the process in a row and to get it involved and to test it in a production critical environment. That is also a large challenge to do, because you have to work very often with some kind of simulators or integration servers. And that means you can simulate a lot of stuff, but in the end, at some point, you have to try it at the real production site, at the real production data, and then hopefully you have tested everything enough so that it works without any failure. That's the thing. It is possible, but you have, of course, to take care and test a lot and talk about with every participant so that anybody understands where the challenges are and that everybody's prepared and everybody knows what could happen and what will we do when something goes wrong, when something happens, what would be the next step and so on. If you prepare such things with all the participants, then you won't have a bad experience.
Fantastic. So getting people involved and not doing it quickly over a lunch break, it sounds like the right approach for Mercedes. Very good. And Rick, perhaps if I can come to you as well, in the transit world, you mentioned in your presentation about integrating, I think, with Trapeze, which is a popular system in that environment. Is that the only integration you did? Was there anything else that you worked on in terms of integrating different applications, or is that something you're thinking about for the future? Rick, I think you may be muted, Rick. You might need to come off mute.
Oh, sorry. Actually, okay. It's Hastis. That's the scheduling software we've interfaced with that assigns the buses for us. So it's a one-click deal for dispatchers to save their time. Future interfaces. I guess it's yet to be determined. There's many ideas being kicked around.
Fantastic. Thanks for sharing, Rick. I've got another question here, which actually, Edmundo, you might be able to help us with. We've talked about ultra-wideband, and one of the questions that's come in is, did you experience any interference or disruptions when you've used it in a factory setting? So how did you find the ultra-wideband reliability, I guess, is the question.
No, there is no interference. In our case, we use many type of devices like AGVs, automatic chariots that go all around the assembly line. And there are a lot of inductive and infrared devices. There's no interference in the 2 years almost 2 years in February that we are testing this system in this Ubisense technology in the assembly line in Vigo. So it's perfect.
Excellent. Thanks for sharing that. Yeah, that's what we like to hear. Thanks for sharing that, Edmundo. I had another, I guess, more technical question. Lauren, this one's for you. Someone's asked, were you using active or passive RFID in your facilities there in Hamburg?
Passive. So it's all triggered by the gates.
Fantastic. Thanks. I think that comes back to something Andy was saying about picking the right technology on this kind of cost performance, benefit scale. Fantastic. Great. Another question I quite like here. I'm not sure who I'm going to ask you to. Maybe Rick, we'll start with you. You've got a long experience here with Ubisense, but is there anything that still surprises you about the product? Things that you weren't expecting that you wish you'd have known, 2, 3, 5 years ago when you were embarking on some of these projects?
Well, I'd say probably it's more robust every time. Every new map that we have come out, we can do more stuff and provide more information to users.
Okay, so thinking broad about the data that you can use and the possibilities, I guess.
Exactly. And Ubisense is very easy to work
Fantastic.
with. They allow us to use different, connect to different systems if we can get everyone together and figure out a way.
Great. Wolfgang, maybe I'll ask you the same question. I know you've got a long experience here with Ubisense. Are you still getting surprised by things? Or what's the last thing that really surprised you with the system?
Hopefully not. No.
Okay.
So we're not getting surprised by the system in general. So Ubisense ultra-wideband locationing system does exactly that, what it should do. And I mean, in general, it is. It starts all with the design, with the first design of the installation itself. So that means if you know that you have an difficult environment with a lot of metal inside, with cables, with everything, with corners, with edges, with whatever, cables everywhere, and with a lot of disruptions and so on. So if you take that in advance at the very beginning, and you get a good level of sensors everywhere, then you know that you won't have any surprises, because you have a good density of sensors all over your assembly line, and then you won't have any bad surprises, or you won't reach any point where you say, oh, we didn't think of that, now we have a problem. Perhaps sometimes it's sufficient to do another or some additional sensors there installed, but then normally every trouble or problem would be away. So in my time with Ubisense, I couldn't tell you that we had some kind of weird bad experience or a surprise with something we didn't calculate before. When we had something surprising, then it was always a connection between a lot of different factors that came together, with interfaces with other systems, with some weird process or anything like this. So in general, I couldn't tell you anything that we had bad surprises with the system anywhere.
Okay, great. That's good to hear. So the fewer surprises, the better. That's a good way to think about it. Thanks so much. I had another quick question here. Perhaps Edmundo, this is one for you. Somebody's asked about Stellantis and said, how did you measure the success, of your project? Were you looking at productivity or quality, or was it a mix? What was the driving thing that you look at in terms of judging the success of the project you have there?
I think that the main gain is time that means people and money at the same time. Our major objective was to reduce the rework product time due to the unfinished operations. And this is time, and at the same time it means people that has to do the rework, and it all means money. That's the high gain of our project, and I think we have achieved it.
Fantastic. Thanks, Edmundo. Actually, I think that's probably the perfect way to wrap up the session today. Time is money, and I'm conscious we're taking up people's time here. We've got a few more questions on the panel, but what I'd suggest is we'll follow up with from Ubisense, and we'll connect people together and be able to answer any of those outstanding questions. So I'd like to finish by thanking again all of our speakers for spending their time, sharing their insights today. Quick reminder, you can download different assets from this presentation and this event. If you look at the bottom of your screen, you'll find a section where you can click to download, and you can also click to request more information depending on what you need. I'd also like to close with just a short announcement that our next live event will take place in Detroit next year, where we'll have more great speakers, more exciting product updates, and because 2022 is actually the 20th year, the anniversary year of Ubisense, or maybe even have some birthday cake for people that can join us in person. So hopefully we'll be joined by Andy and our speakers here today as well. So with that, thanks so much for joining. I hope you enjoyed this session, and we look forward to seeing you next time. Thanks.